All right, so everyone, shall we continue? So the next one we look into is on the BGP requirement implementation and also the troubleshooting on the different cases. They have over here, they're doing as a case one and also on the case two. So for this requirement here, OSPF run in AS100, all router belong to the area 0. IBGP peer relationship are established between directed connected router using the address of loopback 0 interface. The number of BGP connection to establish is minimized. Okay, that is on be done, but IBGP need to form using loopback 0, and the number of BGP connection need to be established into the minimized. For the minimize over here, they require make sure that the configuration need to be using a peer group. Okay, minimize. And R5, R6 are using loopback established on the IBGP peer relationship. R5 use direct interface to establish eBGP between R3 and R4. Use loopback interface to establish BGP with the R7. Okay, this is on the loopback, and these two as a physical. Okay, that is what we have on the configuration on the second question. And R1 is directly connected to 168.0.0. R2 is direct connected to the 1.0, and R7 is directly connected to the 2.0. And the three network segments must be able to communicate with one another, and the number route on R6 must be minimized. Okay, so that is what we are defining from here. So from here, we're going to perform on R1, R2, R3, R4, 5, 6, 7. So for OSPF, it's already been predefined. So it's nothing worried on that. And so we're going to just configure the configuration over here first. So to the neighbor BGP connection is to be established in minimize. So it means that it's better that we're going to have a route reflectors. Okay. But from this, they have some of the route reflector configuration if it's slightly different. Let's follow whichever they provided. Let's follow my configuration. We do it step by step on router 1 up to router 7. You find out that what are the things we need to troubleshoot in this case. Okay. How we're going to implement the troubleshooting in this case number 1. Okay. So for the OSPF, it should be already done. Okay. You can check on the configuration. Okay, so I configured. I also bring up the notepad. All right, so I'm going to check on router number 1, display IP route protocol OSPF. So you can see that R1, R2, R3, R4 OSPF has been done. Okay, between 1, 2, 3, 4, and also from the router 5 and router 6. Okay, displayed OSPF, display IP route protocol OSPF. So you also have a peer to 6.6 already done. Okay, but 5 to 7 later we need to using a loopback. We need to think of a way what we can perform on the peer between 5 and 7. Right now, just just follow the configuration that I configured to form the problem and show you the problem and how we're going to solve the problem. Okay, we do it on router number 1 first. Router number 1 is just do a normal peers. Okay, from here we're going to define like this: router 2 as a RR. So I can say that this RR1. and router 3 as a RR2. Okay, and that is a client of RR1, and this is a client of RR2. So this is how the tricky things happen. Let's say you're going to have a different RR with different client. So it means that in this case, that is running on the non-client relationship. So between this is not consistent. R2 here's client and R1 is here's. So it's not really consistent. Let's see what is the issue after we're done on this configuration. Okay, ready? First, I start on the router number 1. Ready to go? BGP 100. Okay, peer to 2.2.2 AS numbers 100, peer to 222, connect interface, loopback 0. Okay, that is on router number 1. Router number 1 just peer with RR, router number 2. So I go to router number 2 right now and perform that BGP 100. Peers 1111, AS numbers 100, peer 1111, connect interface, loopback 0, peer 3333, AS numbers 100, peer 3333, connect interface, loopback 0. And then IPv4, family, unicast. I'm going to have this information as a peers 1111 reflect client. Okay, and also I will have a peers 1111 next hop localhost. It's okay so far? So this is on router number 2 that I require to do. Oh, sorry, this I should copy this. Okay, R3. R3 is a RR2. So BGP 100. So I have a peer to 2222 AS numbers 100, peer 2222, peer to 4444, peer to 10035.5. Okay, they have one peer to the router number 5, IPv4, family, unicast, and peer to 4444, reflect clients, peer to 2222, next hop localhost, peer to 4444, next hop localhost. Yeah, this is what I have from here, sir. Another tweet. 123, and also router number 4. Router number 4 is just a client of the RR2. So it's just pretty simple. BGP 100, peer 3333, AS numbers 100, peer 3333, connect interface, loopback 0, peer 10045.5, AS number 200. That's all. So far, okay for the first areas. So far, okay. Done on the area number AS number 100. So after that, I will continue with the area AS 200. Okay, on R5 and R6. Okay, on R5, just now you mentioned that I need to form the peers with 3 and 4 using the physical, 6 using loopback, 7 using loopback. Okay, these two using a loopback. So how I define the loopback information from here is, first on router 5 is BGP 200. Peers, I will have 6.6. Just check carefully. I'll just check one more time whether what's the question they asked already. 5 and 6 using loopback. R5 direct connect between 3 and 4. Loopback for outer 7. Okay. Okay. Peer 6.6.6, AS numbers 200. Peer 6.6.6, connect interface, loopback 0. Okay. Then after that, I'm going to have peer to 10.0.2035.3. AS numbers 100. Peer to 10.0.35.45.4. And peer to 777, AS numbers 300. Peer to 777, connect interface, loopback 0. Peer to 777, eBGP max hop 2. Okay, this need to be done. But for me to able to done from 5 to 7, you have one more requirement. You need to make sure that from router 5 can ping to 777 first. When it cannot be communicate with 777, it means what? You mean your peer will never form. So I need to add this IP route static 777 32 point to 10.0.57.7. And that is how I can go to the destination. Okay, at least I have route how to go to that. I will check ping to 777. It can respond. So it means I can form the loopback and at least make sure that it's pingable first. Okay. And router 6, you do the same thing. Sorry, before that, let me just copy this. Okay, this needs to be done. Router number 5. Router number 6, BGP 200, peer 5555, AS numbers 200. This one's pretty simple. Okay. This router number 6. All right. And the last routers, router number 7, BGP 300, peer 5555, and also you need to build this 10.0.57.5. Okay. Make sure you can ping. That is the way of doing on router number 7. All right. So make sure that you have copy all these things information first before we can proceed. So I put here for 30 seconds for you to make sure you are inside, then we can continue. Okay, so far all right. Everything following can proceed. Okay, next look back into the question first. Okay, look into the question first. So you see that R1 is direct connected, R2 is direct connected to this network, and R7 direct connected. These three networks must be communicate with one another's. And the number of the route on router 6 must be minimized. So it means that I need to do the summarization on router 5 to make sure that router 6 is only receive the summary route of the 192.168.0.0. But before this, I need to advertise this route into the BGP first on R1, R2, and R7 and perform router 5 doing the summarization must be the two suppressed sent to router 6 because router 6 only must be minimized route they can receive. Is that okay? So far, based on the question. All right. At the meantime, you just let me capture another attendance for this afternoon. All right. Just a quick one. All right, let's come back to this. So right now, the question said that 1, 2, and 7 need to advertising the environment into the BGP. So first, we advertise the network into the BGP first. Okay, ready? So I'm going to do is on router number 1. From here, I will just go to the IPv4 family unicast. Okay, network 192.168.0.0.24. Okay, and router 2. Okay, router 2 under the IPv4 already. Network 192.168.10.24. Just add this into router number 2 and router number 7. BGP 300. IPv4 family unicast. Network 192.168.20.24. Just advertise this in router 7. Okay, ready? Just double check on router number 6 what you're receiving on router number 6. Okay, router number 6 displayed BGP route. At the moment, you receive 3 of them, but both 3 of them is not the best valid. So in this case, router 5 need to do something already. Router 5, just now I forget one thing. On router 5, add this information, BGP 200, IPv4, family, unicast, peer to 6.6.6. Need to put this next hop locals. Make sure the route is activated. Go to router 6. And make sure this has been done first. Done. Make sure this one is activated. Make sure router 6 see all the route is a valid and the best. And I'm going to put this into router 5. Okay, add one more line inside to make sure that that is what they should do. Okay, so far. Okay, so next I'm going to follow by the summarization. Summarization done on the routers 5. How I'm going to do the summarization on router number 5 to make sure that that can be only minimized route will be sent to the router number 6. Okay, only summary route sent to the router number 6. So what should I going to show you from here is I need to go to the router 5 to do the aggregation. Okay, to do the aggregation. Hold on. All right, so on router number 5, I go out from the BGP point. I specify the aggregation to make sure that they receive only the summary route. So I put the aggregate 192.168.0.0, 255.255.252.0. I put, let's say I put the AS set, or without the AS set or AS set. So what do you think? I will just put the detail suppress. Let's see what happened. I'll show you the result from here. Detail suppressed already. Okay. Wait for a while. Router 6, it should receive only one single route. Okay. After you're done on this, let's check. On router number 1, you get the route already. Let's try to do a ping. Ping minus A 192.168.1.1, 192.168. Sorry, this is 0.1. Let me double check the address from here. 2.7. Okay. R1 can ping. How about R2? Ping minus A 192.168.1.1, 1.2, and 192.168.2.7. Okay, this can ping. So you can see that everything is fine for them to ping in between. And on router number 6 is receive all the information. It's originated by router number 5. Let's say right now I go and try, instead of using the 2 suppress only, I just put the AS set, okay, to doing the loop prevention. Okay, to doing the loop prevention. In this case, after it's done, router 6 display BGP routing tables. Do you see what's the difference between these? Router 6, first before the AS set, I receive from the I. After the AS set is bracket 100, is a curly bracket 100, 300 I. So it means that they have the summarization is come from AS 100 and also from the AS 300. They come from two AS, from 300 and also from the 100. But after I've done on this, let's check again. Can R1 go to 2.7? It's not possible anymore. Why? Because I have no default route generated by router 5. Router 5 will not send me the summary route. Displayed BGP routing tables. You can see that I only can go to 00 and 10. I cannot go to the 20. So what happened that I put the AS set. When I without AS set, I show you one more time. Without AS set, for R1 to go, you can see that I will have at least a summary address for me to go to the destination. So sometimes it depends on where you're going to use the AS set. So it will be need to be very carefully where the network need to be communicated to where. Okay, they need to talk to each other. Then in this case, you need to open up the summary address to allow the router 1 to router 7 can be talked to each other. Otherwise, this is an issue already. In this case, R1 and R7 cannot communicate. R2 and R7 cannot communicate. Only R1 and R2, they can communicate. They can ping minus A 192.168 192.0.1 to 192.168.1.2. Okay, this can ping. Within the AS, it can ping because I learned the route, and now I should able to go to 2.7 as well because I have a default gateway to go already. Not default gateway, my summary route. When I display BGP routing tables 192.168.2.0. So it show me that it's going to use this as your destination, as your next hop to forward to the destination. Is it okay or not for so far for this lab? Is it okay so far? So in this case, it seems like it's not very difficult to do, right? It's pretty simple in this way. How we set the information is pretty simple. Okay, so that is you need to know that after this lab, actually what they're going to be emphasized over here is just to tell that on the summarization that you perform, you need to know where they can access to where. Okay, where they can access to where. So that is important things that you need to be aware where you should do. Is it okay? So the next one from here is go back to the slide from here first. So for requirement, this just now already done. After summary route, you can find out what we're going to do. Okay. So over here, the configuration file of the device is a bit not correct. Okay, I can say it's not correct. So you need to be aware when you configure on this information. Because by right, the information over here is not fully correct. You just have to make sure that you do it properly. Because based on the diagram, 1, 2 is on the left, 3, 4 is on the right. But you can see that on the 1, 0, they advertise is under router 4, not under router 2. So there has something wrong from here. So actually, it's not a correct configuration. The configuration that I showed to you, that is a correct configuration. Let's say I want to copy, you copy the one that I show from the notepad, okay, on the notepad. Same to this. Yeah, that is, seems is correct, but I'm not sure how come they have one extra for this. This one, it should not be appears. Okay, this one should not be appears. And they must define the static route for them to make it work. Okay, to make it work. And after the configuration is complete, all BGP peer relationships are established. Two network segments as AS100, however, cannot access the network segment into the AS300. It because of they have no route. Because you are putting the AS set. When AS set when detected, I will not go back. So in this case, they're not able to perform. All right, that is the reason. So after you solve this by using a detail suppress only, then the peers you should be able to ping between routers 1 to router 7 already. So for this implementation and the troubleshooting under the case number 2, these cases actually is more to check on the client route reflectors. So you can see on this, on the AS100, all the 6 routers is belong to AS100. They're running IGP, okay? IBGP with the loopback 0. The peer relationship are shown into the figures. So the peer relationship will be something like this. R1, R4, R2, R3. Okay, R1 is a client of R4. R2 is a client of R3. Something like this. Okay, then this R5, R6 connecting. All the eBGP peer from R7 to R5 and R7 to R6 using direct connected. To enable all the router to learn the route of the AS200, configure RR. R5 is a client of R3. R6 is a client of R4. Okay, so that is on the, sorry, R1, R2. So R5, R3, R6, R2, R2. And this is on the R1 pair a normal pair with R4, R2 pair with a normal pair with R3, just a normal pairs. Okay, so that is what we're going to be performed on the case number 2. Okay, that is some of the configuration. So from here, let me just share you the lab first. We also do it together. Do you want the complete lab for this? Do you want me to save and send to you? Okay, let me just save it. So this is on the case number 2. So I will share to you as well, and we can do it together. Okay, just let it start first, then we're going to do it together. Okay, download it and just open up. Then we can continue with the number two, case number two. This case number two, most likely we're going to consider on the route reflectors, how we define route reflectors. Is all of yours started already? Mine is already started. How about yours? Can I start from this for the case number two? Okay, so in this case, we're going to based on this to perform the changes of the configuration. So it can be see that R3 is a RR for R5, R4 is RR for R6, R1 is a client. It's not client. It's just a normal peer with R4. R2 is just normal peer with R3. Okay, this is a normal peering in between. Okay, so in this case, we need to check carefully what we should define from here. Do it step by step. All right. So let's check from this configuration. Let me open up everything. All right. So I guess start on router number one. Okay. Router number one. So let's check display IP route protocol OSPFS. So you see 1, 2, 3, 4, 5, 6 is already there, except the 7. Okay, no BGP configured. So right now we configure BGP. Ready? So on the BGP 100, peers is to 4444, AS numbers 100. Peer 4444, Okay, and advertise a network 192.168.1.0 that is on the 24. Okay, sorry, my mistake. It's a network 192.168.0.0.24. Okay, I will just copy this into the list so you are not confused. That is router number one. Okay, router number two. Router number two just pair with the router number three. So it's just BGP 100 pair 3333. Okay, and next router number three. So from here, I'm going to how many peers I have. So I have peer router three have peer with router two, router four, router five. Okay, always we refer this peering this method lah. So R3 have two peers, one peer to R2, one peer with R4, one peer with R5. Okay, have three peers. Remember, R3 have no peer with R1, R3 have no peer with R6. Okay. All right. So I peer to 2222. Peer with 4444. 5555. Okay. So I have a 4245 and IPv4 family unicast. I need to have a peers 5555 reflect client. Okay. So that's all for the router tree. So for router 4, you'll be doing the same step that we have on router 3. So router 4 have peer with R1, R3, and R6. So on router number 4, I'm going to go to BGP 100, peer with 1111, AS numbers 100, 3333. Okay, peer 6666 as a reflect client. Yes, router number 4. Okay. So far up to this point, any questions? Then I go router 5, router 6, and router 7. Router 5 is a BGP 100. Only have two peers. One is on the 7, one is on the 3. Okay. Peer to 3333. Ten zero 57.7 200. Okay. And also for the peers, sorry, just now I should have added this next hop locals. Okay. So this line, it should be this. Yes, local. Then actually it'll be the same line. Doesn't matter. Okay. Then router number 6, similar to router number 5. BGP 100 4444 4444 and followed by 10.047.7. Okay, that is for router number 6. Okay, router 1 through 3, 4, 5, 6 within the AS. That's how we defined. Okay, then last router is router 7. Need to advertise one network and two peering. BGP 200. Peer to 10.0.57.5. Peer to 10.0.47.4. And IPv4 family unicast and do the network 192.168. So what's the network defined? It should be 10.24. Okay, display IP interface brief. Oh, there's 2 zeros. Okay, so that is what I define here on router 7. Oops. Okay, that is configuration on router 1 to router 7. Okay, router 1 to router 7. So far, okay? So let's have a look. Can your router number 1, after you've done all this, router number 1, display BGP routing tables. I only have 00. Let me double check. Router 7, display BGP routing tables. I have only 20. Somewhere it's not advertising. Let me double check. Display BGP routing tables. Zero zero is not advertised. Display BGP route 192.168.0.0. That is an issue. My mistake. This is not 47. BGP 100. Display this. Undo peers 10.00 47.7. Peer 10.0 67.7. AS numbers 200. 67. 67.6. Okay. So for me, I need to go back, display this, undo peers 10.0.47.4, peers 10.0.67.6. Yeah, let it up the peer first, let it come up. Okay, establish display BGP route. Okay, I should receive this. This also should receive the same things. Okay. So right now on router 1, I learned this already. Let me try. Do a ping minus A 192.168.0.1, 192.168.2.1, 2.7. Do you able to tell me why this cannot be pinged? Why router 1 cannot ping to the router 7? Okay. Let's say router number 5, I learned this information. 5 and 6. Okay. So from router 1, go to 192.168.2.1 of router 7. Okay, on here. So you see that which path I go first. Router 1, display BGP route 192.168.2.0. I will send to from 4444. How I go to 4444? So I send to router 2. Okay, this is my path, right? Go to 4444. I send to router 2. Router 2, display BGP routing tables. So For 192.168.20, go to 5555. How to go to 5555? Display IP route 5555. I go back to 10.0.12.1. Okay, like this. Traced minus A 192.168.1.0.1 to 192.168.2.7. So you see that how the path it be forwarded to. So if first you go to the 10.0.12.1, 10.0.12.1, you see that it keep on coming back to yourself. Okay, keep on coming back to yourself, coming back to yourself. You can see that the message is never able to go out. Okay, why we have this issue in this case? All right, let me just explain. This is a problem when you doing the peering from here. Do it differently. Okay, because right now the peer is something like this. So that is a peer of R4. They have IBGP. I have IBGP. Okay. So whichever I have, I send to R4. Okay. Because this is the two peers. These peers, I will send these directions. Send to these directions. Okay. So R3 did not learn this information because of this is a non-RR, non-client, this non-client. Whichever I learn from here, I will not send to the next non-client. So R3 will never know how to go to 10. Okay, that's why just now when I check from this routing tables, R3 display BGP route, they do not have this 100 because of when router 4 display BGP route, I learned, but when I check details, I only send to 6.6.6.6. I will not send to the 3.3.3.3 because it's IBGP. I will not send to the next IBGP. Okay. So in this situation, actually, they do it a bit wrong because of you can see that the RR is here, this RR is here, but the peer that form is across peers. So whichever I want to go to R4, I have to pass through R2. When R2, also we check the routing tables to tell that, oh, when your next hop is the 5555, I need to go to this direction. Okay, go to this direction. Okay, because right now R1 R1 learns about 192.168.2.0. The next hop as 6.6.6.6. And R2 192.168.2.0. The next hop is 5.5.5.5. When I want to know that, oh, want to go to 6.6.6, this by right should be my path. Am I right? 6.6. But when you're up to router 2 on this interface, I will check, oh, you want to go to 192.168.2.0, 5.5.5, this way. When I'm up to this point again, they'll check the routing table again. Oh, go to 6.6.6, don't come to me. Again and again. They will keep on bouncing each other and not able to go out in this situation. So far, do you get the ideas of this? Why this happened? Why this happened? Because of when this connect to the RR, not RR, connect to this IBGP peers, they are not defined as a full mesh. So some of the route they learn, some of the route you have not learned. So that's why we always mention that you must form a full mesh connection, even though you do not want to use a route reflectors. Okay, even you're not doing route reflectors. What should I do to solve this? Actually, R3 is a client. This is client, and also this is a client. You should have all the client as a full mesh for them to able to easily access out At least that R2 will learn direct from R4. Okay, it's not learn through this path or not learn through this path. Okay, so that will be the mistake they were going to form on this troubleshooting case number 2. To solve this, you need to form a better peering in between. You can just do a IBGP in between. Okay, IBGP in between in this case, at least that they'll know that that will be the best path for them to go. For R4 and R3 send you the route, you select this as a best or this as a best. Okay, you should need to perform the exchange route when you exchange from R1 go to the R7. Okay, let's us just to do the testing from here. I will just do the configuration here on R3. So instead of only have peer with R2, I will just do another peers. I will just say that peers 1111 AS numbers 100. Peer 1111 connect interface loopback 0. Okay. Same case to the router 4. I'm going to add the peers 2222 AS numbers 100. Peer 2222 connect interface loopback 0. Okay, I will just add this. And on R1's BGP 100, peer to 3333, AS numbers 100. Peer to 3333, then followed by the connect interface loopback 0. Peer 2222, AS numbers 100. Peer 2222, connect interface loopback 0. Can make it a full mesh. And R2, peer to 1111, AS numbers 100. Peers 1111. Okay, we should do it as a full mesh connection. Display, just hold on. Just let about 30 seconds for let the peer to form before I show the result from here. Okay, so let's have a look. What's the result from here? Display BGP route. Okay, at least right now they get a better idea of information. Router 1, display BGP route. Okay, so in this case, let's just try one more time. Ping minus A 192.168.0.1 192.168.2.7. So you should be able to ping properly. Okay, from router 1 prefer this path, from router 2 prefer this path. So that will be the better ideas. Instead of you do not full match the devices, you somehow you do the cross connect, then you will even make the things even worse. So that's why for us to perform the BGP configuration, you need to think of when the peers you form as a cross, then the route that you learn, it might be also having the issue already. Okay, that is what we need to think of. So that's why this one is not able to go out after their full configuration. They found that request timeout on these devices, and the rest are okay. Okay. So for this case summary, they will say that do not configure a peer relationship between an RR and a client through a non-client. And do not configure a peer relationship between the RR and the non-client through a client. And do not establish a IBGP peer relationship between the RR and client and an RR client and non-client. Okay. So that is the things that you need to be aware that should not have this. Okay, but by right, what we facing just now is no, we do not have any. But this is a RR. This is a RR. This is a client. This is a client. Just that we configured the non-client through this way. Okay, non-client through this way, like this. But in this case, it's also having the problem already. Okay, because of that's okay. This is okay actually. Yes, the RR to RR to non-client is going through these two devices as also not full IPGP connection. So that will be the drawback. So, but the best way we're doing so, you can just make everybody as a client. From this RR to make all the devices as a client, you'll be solve everything. So this is on the design issue, the design problem in this case. Okay, this is on the case summary on the case 2 under the advanced BGP topic. So far, is it okay? So do you want the result for this? You want me to save the result and put it to the notepad? So this is what I added to solve everything. This is what I added. Okay. All right. So I share already and also the notes. Okay. So for this advanced BGP, any questions so far? So let's say there are no question. Let us do the quiz from the last two questions from here. So what are the quiz showing from here? So the first question is when the RR reflect the route information sent by IPGP, the RR cannot modify any attribute. True or false? So the answer will be true. Okay? Because RR is just reflecting the traffic, just reflection. So they do not change any information. Whichever they have, just reflect to the peers. So please describe the classification and also the precaution for route summarization. So first you need to know on the route summarization, we divided to auto and manual. Auto only support under the import route. Okay, and this is a classful summarization. Only for auto is always doing the classful summarization, but for manual, how they summarize on the manual? manual, they can summarize anything as a classless information. And from the manual, they also involve of the AS set. Detailed, suppress. And what else? Origins, policy, attribute, policy, and suppress policy. So they're going to have all these features can be added inside the manual summarization that you might need to be aware and doing some precaution on this, because not everything need to be as that. Not everything need to be detail suppressed. Not everything need to be origin policy. So you need to know in what situation which one we should use, which one we should not use. Okay, that will be important on the route summarization. It can be created, can be done into the BGP. Is it all right? On the summarization of the route summarization. And this is on the section summary. Deployment solution when mesh BGP route are used. This is a way. Using route summarization, peer group, route refactor, confederation, and also community attribute. And for the internet design fundamentals, what type of network need BGP, how to optimize the BGP, and how you configure advanced configuration of the BGP at once. Okay. Let's say you want to get more ideas about all other protocols, all the advanced protocol or extended protocol. Over here, you can check on the confederation, the protocol 4, BGP 4, extended community attribute, an alternate to full mesh internal BGP, route reflections, and also multi-protocol BGP 4 plus, and support 4 or tag AS numbers. So this is all the IFC. They are standard from this IFC. So you can refer back into this document to get more detailed information. So this one is more to your self understanding and also self improvement. Let's say want to get more ideas on that, you can just go in through this IFC document. Or otherwise, they also can have a recommendation from the website, from a Huawei support website, and also for the case library that has been used on the physical case, the live cases are used into the environment. So you can also refer to this. All right, this is on the recommendation. So far, it's okay.